Hello, my name's James. I was a science teacher for about 10 years. I'm currently working at home because of the coronavirus, COVID-19. And I thought I'd do some lessons whilst working at home. So the objectives for this lesson are to investigate how a pathogen can spread, to describe exponential growth, and to analyse and evaluate the best way of controlling the spread of COVID-19 using model simulations. So first off, what are pathogens? So I want you to have a little think about this yourself. You can write down answers, you can draw, you can verbally explain it. But it'd be really good if you then recorded this in some way and sent it in so we could all share our knowledge and put it all together. That would be really cool. So the GCSE answer, so pause there if you want to do it yourself. But the GCSE answer to what is a pathogen is that pathogens are disease-causing viruses, bacteria, fungi or protists which can infect animals and plants. Humans have an immune system which can defend them from pathogens. So thinking about pathogen spread, what makes COVID-19 spread so quickly? Again, I want you to have a little think about this, try and write down your own answers. You can draw them if you like, annotate a diagram or verbalise it, record it and send it in. Some of the ideas I came up with were that it's a new disease, so it's something that's completely new to humanity. No one, when COVID-19 originated back in 2019 in Wuhan, China, had any immunity to this disease. So this is something that could potentially infect all of humanity. No one's got any immunity to it, so we're all susceptible to getting it. It's also highly contagious, so compared to the seasonal flu, where about 1.3 people are infected by every one person, COVID-19 has a spreading rate of about 3 people. So for every one person, they go and infect 3 people, who will then go and infect 3 more, who will then go and infect 3 more, and so on. Another reason why it spreads so quickly is that we're a global community, so people travel around, move about all over the place, and that can help to spread the disease. There's probably many more, so if you can think of any more reasons why COVID-19 is spread so quickly, please send them in, that'd be brilliant. So as I've already mentioned, if one person gets the flu, on average they pass it on to another 1.3 people. With COVID-19, if one person gets that, they normally pass it on to approximately another 3 people. What I want you to try and work out is how many people they pass it on to if this process repeated 10 times for each one. See, with the seasonal flu, you've got one person passes on to 1.3, that person passes on to another 1.3 and so on. So I want you to try and work out how many people they're going to pass it on to. So one way of working this out is to do 1.3 times 1.3 times 1.3 times 1.3 10 times, so 1.3 to the power of 10, and you end up with 13.79 people infected. If you do this with COVID-19 and do 3 to the power of 10, you end up with, so 3 times 3 times 3 times 3 and so on, you end up with 59,049 people infected. However, I don't think this is entirely accurate. Can you actually spot maybe what might be a problem with the math here? So in reality, one person infects another 3 people, then you end up with 4 people infected. Those 3 people, then times by 3 again, because they each infect 3 people, end up with 9 people infected, but you've got to remember the original 4 as well and add that on, giving you 13. And this goes on and on. I've done a little example of this with some cat food. So with my cat food, we've got the 1 originally here. They infect 3 people. So then at that stage, after it's repeated once, you end up with 4 people with COVID-19. If this then repeats, those 3 people who are newly infected infect another 3 people. they infect a total of 9 people, so they're newly infected 9 people. But in total, we've got those 9, plus those 3, so 12, and then plus the original 1, so you end up with a total of 13. So more accurate numbers for people who will get infected would be about 56, 57 people with the seasonal flu, assuming that each person infects 1.3 people. And with COVID-19, after 10 repeats, you're probably looking at about 88,573 people infected. So that just shows how highly infectious COVID-19 is and how important it is for us to take these distancing measures to ensure that we're not spreading the disease. Right, next I want to try a little activity. So I've made some sticky little pathogens of my own. I've made mine out of newspaper and some sellotape because that's all I could really find that would work. But get creative, you might have other things around the house that are sticky. Obviously ask permission before you go ahead and do this, and try and make sure it's safe as well. We don't want any sort of killer Lego blocks on the stairs attacking unsuspecting victims or anything like that. So try and keep it safe and fun, but you can make some models of some COVID-19 and try and get an idea of how they can spread around, how they can stick to things. COVID-19 is known as the coronavirus. That's because the spikes that are on the outside of the virus look a bit like a crown. COVID-19 is sticky and spreads around. It can spread by coughing, it can spread by sneezing, and it's been found to hang around on surfaces for a number of days. For example, recent research is suggesting on plastic and metal surfaces it can hang around for about 48 to 72 days. It's also been found on a Diamond Princess cruise ship 17 days after the passengers all departed, so it's still on those surfaces hanging about. I've made these sticky little bits of paper to try and illustrate how the coronavirus can stick to things and spread around. So imagine you have a cough, it can hold up in the air. Some of it does settle down to the floor, but some of the virus also hangs around in the air. It's very sticky, so it will stick to you, so it's stuck all over my hands. I've coughed into my hand and now I'm wiping my face. Oh, I'm getting coronavirus all up inside me. That's not good. I might become infected. It might also, then I might walk off and I'll stick it to might end up getting stuck to a door handle on a metal surface. Other people are going to come through and use that door handle, so that will help. That will also spread the disease. So you can get a good idea of how contagious it is. You can try this at home, make your own little coronaviruses, stick them to things, see how many people you can infect. What is exponential growth? So the same procedure again, write, draw a diagram or graph, or verbally explain what you think exponential growth is. Exponential growth is growth that increases by a constant proportion. You might have encountered this before when you've looked at compound interest in maths. So for example, if you have opened up a savings account and you're getting 1.5% interest each year on the money you've got in there, then this will gradually increase compound interest with time. So for example, I want you to try and work out, if you started with £2,000 in a savings account and you had 1.5% interest, how much money would you have at the end of 4 years, and how much would you gain each year? So we're saying it's 1.5% interest per year or per annum. So you start off with £2,000. You've got your 1.5% interest, so you work out 1.5% of 2,000. Different ways to do this. I divide by 100. So I end up with 20, and then times 20 by 1.5, which gives me 30, and then you add that on, so you end up with £2,030. Then you do the same thing again, but you start with the 2,030 this time, so that's why it's compound interest, it's adding up. So you then work out 1.5% of 2,030 and add that on, and then it carries on and carries on. And that's the idea of compound interest, and that is a form of exponential growth, with the growth constant being 1.5%, and it's over a year in this case.